All right, so let's start with these graphing questions. 3 times 2 to the x minus 3 minus 4. What color should I graph the parent in? Red it is. Goes through the point 0, 1, the point 1, 2. All right, let's stop talking, please. Okay, so there's your parent function, 2 to the x. I now want to vertically stretch that by 3 and then shift it right 3 down 4. So this point right here, the point 0, 1, it is going to become the point 1, 3, or sorry, 0, 3, and then go right 3 down 4. And so you now have the coordinate positive 3 comma negative 1. The point 1, 2 is going to stretch up to be 1, 6, and then go right 3 down 4. So it now has coordinates 4, 2. And those aren't the only points. You know, sometimes if I saw you clearly didn't plot those points, I was quick to take a point off. But then sometimes I would notice, well, they actually plot another point. Let me verify that that point was actually accurate. So if you felt like I messed yours up, please let me know. And then the vertical asymptote gets shifted down for, or sorry, horizontal asymptote. And so your final answer is a nice, happy exponential like that. Cool? Number 2 is a log base 3. So again, I'll graph the parent in red. That is going to be going through the point 1, 0, the point 3, 1. I don't know why when I printed this to this program, the grids got all chopped off. That was weird, right? Then all we got to do is shift that left 4 down 2. So we have a point at negative 3, negative 2. We have a point at negative 1, negative 1, and a vertical asymptote. Oops, I'm supposed to be doing this in blue. How do I know if it was where, what way, what way, how way? Well, if you got the points like that, there's only one way to go.
No, because
it's got a purchase vertical asymptote.
Yeah, but you can also try.
Going up?
No, like a backwards L. Yeah.
But then going up? The right side of the vertical asymptote?
Yeah, sure.
Well, first of all, logarithms don't have any hills or dips. There's no way it should be decreasing and then all of a sudden switching to increasing. It's either always increasing or always decreasing.
That would be a good point to know.
Right. Right. It's the inverse of an exponential, and those are always increasing. They're one-to-one. They can only have inverses if they don't have hills and dips, right? So by definition of an inverse function, they are always increasing or always decreasing. Always, no matter what. Functions can only have inverses if they are always increasing or always decreasing.
So I didn't see the same.
I'd have to look at it, but I guess.
Yeah.
Probably, I guess. Yeah. How did you drop? So you had to go up?
Well, wait.
Because the examples we did in class had a negative in front of the log, which meant they were reflected. And so they were going down. But this one wasn't reflected, so it should be going up.
Okay.
Does that make sense?
Yeah.
So I think that's why some people got messed up, because we did an example in class that was different. Okay, if you haven't been able to tell yet, all the problems in the quiz are 5 points apiece. And I did award credit for partial, I was able to award partial credit. Some people had the right number, but, for like number 5, the answer is negative 5. Some people put 1/5. But you had the number 5, so you clearly identified 2 to the 5th was 32. So that's important. You just messed up. So minor mistakes, usually we get 2 points taken off. Unless it was extremely minor, then I'd take 1 point off. Okay. Log base 5 of 25. Well, 5 squared is 25, so that makes the answer 2. That's the easy one. Log base 9 of 3. Well, the square root of 9 is 3. So that means the answer is 1/2, because that's how you square root things, right? You raise them to the 1/2 power. Log base 2 of 1/32. So the big thing you need to identify was 2 to the 5th is 32. Well, this also involves a reciprocal, so the answer's got to be negative 5. And then the log base 1/16 of 64. So if we're starting with the number 1/16, you probably first identified there's some sort of reciprocal going on, right? So the answer's got to be negative. And then if I square root the number 16, I get 4, of which I can then do what to the number 4 to get 64? Cube it. And so that's the sequence of events. There's a reciprocal, there's a square root, and there's a cube. So you can do all of that with one single exponent, -3/2. Okay? Some of the more common mistakes were people thought 4 to the 4th power was 64. That was minor. Basically, if you had it negative, if you had a 2 down here, but you just messed up the numerator, I probably took 1 point off. But yeah, that went pretty well. A lot of people wrote -1.5, calculator users. Okay, number 7. So it's going to be 6,000 times 1 plus 0.09 divided by 12 to the 12 times 5 power. I was amazed at how many people wrote that and then got something wrong. Like the people who wrote a final answer where the 5-year investment made you a total of $1.57. A lot of people got that answer, and I don't know what you typed in exactly, but.
You just added instead of multiplying.
Oh, that's right. We did discover that, didn't we? So yeah, that was interesting. Okay. But if we type this in the calculator, now, I was amazed at how many people, like, if you followed along earlier in the week to my lesson, you already had this in there. So you could just say 6,000, 0.09, 12, 5, and then alpha solve. So you get 9,000. How many actually used the solver? Because that's still typed in there. Math, and then at the very bottom of solver. But you didn't need to use that. You could have typed 6,000, parenthesis, 1 plus. This is definitely more presses of the key, but not much more. And then you've got to make sure, actually I don't need to type parentheses because I have this new pretty print. And so there's your 9,394.09. Okay. A lot of people wrote 1,200 instead of 12,000. So that was just totally just misreading the question. I usually don't take points off for that. So that's 12,000 times e to the 0.03 times 15. So we have 12,000 times e raised to the 0.03 times 15 power, 18,819.75. Okay? Or you could have used the equation we had plugged in the math solver, equation solver, right? It just plugged in some gigantic number for n.